Myself Sanjay KV, batch number 2. Today I am going to give a presentation on internship that I have done in the BSNL. As of my interested, I was interested in take internship on the telecom technology. It was a great opportunity for me to do 4 weeks of internship in BSNL RTTC Mysore. This is one of the regional telecom training center of BSNL organization. Here the internship was concentrated on the digital switching systems, fiber optics, computer communication networks, and wireless cellular 4G. These are the contents that are included in my presentation, that is about the company, vision and mission of the company, objectives of company, services provided by the company, and what are the technologies that are learned in the company, that is optical fiber communication and the mobile wireless communication. Firstly, about the BSNL, Bharat Sanchar Nigam Limited was incorporated on 15 September 2000. It took over the business of providing of telecom services and network management from the central government departments of the telecom services and the operations, that is DTS and DTO, with effect from 1st October 2000, ongoing concern basis. It is one of the largest and leading in the public sectors unit providing a comprehensive range of telecom services in India. BSNL is one of the service provider making focused efforts and planned initiative to bridge the rural-urban digital divide in the ICT sector. In fact, there are no telecom operator in the country to beat its reach with a wide network giving services in every nook and corner of the country and operate across India except New Delhi and Mumbai. And BSNL has set up a world-class multi-gigabyte multi-protocol convergent IP infrastructure that provides a convergent services like voice, data, and video through the same backbone and broadband access network. At present, there are 21.86 million broadband customers, including both wireline and wireless broadband. The company experience in planning, installations, network integration, and maintenance of switching and transmission of networks. Next, the vision and mission of the company. Be the leading telecom services provider in India with global presence, which becoming a most trusted, preferred, and admired telecom brand. Create a customer-focused organization with excellence in the customer care, sales, and marketing, generating value for all stakeholders, employees, shareholders, vendors, and business associates. Excellence in customer service, friendly, reliable, time-bound, convenient, and courteous service. Leverage technology to provide the affordable and innovative telecom services products across the customer segments, offering differentiated products or services tailored to different service segments, which means developing a marketing and sales culture that is responsive to customer needs and to explore the international market for global pressure. And next is the objectives of the company to increasing the sales revenue with focus on subscriber retention and acquisition by way of strengthening sales and marketing quality of services and customer delivery, which means to improve the customer care by reducing fault rate and upgrading customer service centers and introducing the convergent billing, which also provides a conductive work environment with a strong focus on the performance to enhance the customer delays towards the BSNL services and to accelerate the pace of the expansion of the mobile and data services with upgradation technology, creating a Wi-Fi hotspots, replacing legacy wireless like wireline exchanges by next generation network, and increasing the BSN visibility in urban and suburban rural areas, like developing a knowledge pool exposed to latest technology advancements and to explore the opportunities in international telecom in like in developing the markets and developing the sales and marketing team with the attitude towards customer care, which means expanding the reach of the fiber network nearer to the customer premises, like particularly in apartment complexes through the FTTH in order to meet the even increasing bandwidth like a requirement for the data and the video applicants, and to improve the productivity by training and skill development and redeployment of the legacy manpower. And the services provided by the BSNL are like a cellular mobile telephone services, internet, IPTV, WLLC, telephone services. Firstly, the cellular mobile telephone services, like the BSNL is a major provider of the cellular mobile telephone services, like using a GSM platform under the brand name Cell One and Excel BSNL Mobile. Next is the Internet. The BSNL provides internet access services through dial-up connections, that is like as a prepaid, net one as postpaid, and ADSL broadband as BSNL broadband. BSNL held 55.76 percentage of the market share with reported subscriber base of 9.19 million internet subscribers, with 7.79 of growth at the end of the March 2010. Top 12 dial-up services providers based on the subscriber base. It also provides online games via its games on the demand (GOD). Next is the IPTV. IPTV. The BSN also offers an internet protocol television facility which enables watching television through the internet to the home facility that offers a higher bandwidth for data transfer. This is the idea proposed on the December 2009. Next is WLLCEMA telephone services. BSNL WLL is, which means wireless in local loop services, is a service giving both fixed line telephony and mobile telephony. And other services provided by the BSNL are universal telecom services, that is intelligence network, IN, IPTV, 3G, FTTH, fiber, help desk, and Vivo IP. These are the services provided by the BSNL. Next is the technologies learned in the company, that is optical fiber communication. An optical fiber is a flexible, transparent fiber made by the drawing glass or a plastic. We learned about the optical fiber communication and did optical fiber slicing, which involved joining of the two fiber optics together. Optical fibers as a wide number of applications. They are used as a light, like a light guides in a medical and other applications, where bright light needs to be shown on a target without a clear line of sight path. In some buildings, optical fibers route sunlight from the roof to the other part of the building. See on the non-imaging optics, optical fiber lamps are used for illumination in decorative applications, including like signs, art, toys, and artificial Christmas trees. Swarovski boutiques are useful optical fibers to illuminate their crystal showcases from many different angles, with, while only employing one light source. Optical fiber is an intrinsic part of the light transmitting, like concrete building production, that is LITRACON. Optical fiber is also used in imaging optics. A coherent bundle of fibers is used, sometimes along with the lenses, for a long thin imaging devices called an endoscope, which is used to view the objects through the small hole. And the principle of operation, and the index of the reflection can be explained in the next slide. And coming to the advantages of the optical fibers, like OFC optical fiber cables are non-conductive, that is dielectric. Grounding and surge suppression is not required. Cables can be all dielectric. This is electromagnetic immunity. Immune to the electromagnetic interference (EMI), like no radiated energy. Unauthorized tapping is difficult. And large bandwidth, future upgrade ability, maximum utilization of cable right of way, one-time cable installation costs, and low loss is a low, and same at all operating speeds within the fiber specified bandwidth. Long unrepeated links, that is greater than 70 kilometers, is operations. And a small lightweight cable, easy installation and handling, efficient use of a space, available in long length, less splice points, security, extremely difficult to tap a fiber as it does not radiate energy that can be received nearby antennas, and highly secure transmission medium. It cannot causes the fire, does not carry any electricity, can be run through the hazardous areas, and universal medium, serve all communication needs and non-obsolescence. And coming to the disadvantages and the application of the optical fibers, like the disadvantages are limited applications and the low power and the distance and the fragility. And it is also used in many applications in many of the fields like medical, defense or government, data storage, networking, industrial or commercial, broadcasting, like a classified communications, which means secured communications, inexpensive light source available, like a repeater spacing increases along with the operation speeds because low loss are used at high data rates. And coming to the splicing types of the splicing, there are three types of the splicing, that is adhesive bonding or glue splicing, mechanical splicing, and the fusion splicing. First is adhesive bonding or glue splicing. Adhesive bonding describes a wafer bonding technique with applying an intermediate layer to the connect the substrates of the different types of the materials. Those connections produced can be soluble or insoluble. This is the oldest splicing technique, which is used in the fiber splicing. Like it has an advantages of the relatively low temperature as well as the absence of the electric voltage in the current. Next is mechanical splicing. Mechanical splicing is a junction of two or more optical fibers that are aligned, held in a place, self-contained assembly. Assembly. They usually the fibers are not permanently joined, just precisely held together so that light can pass from one to other. A very good mechanical splices. The mechanical splices consist of four basic components: an alignment surfaces for the meeting fiber ends, a retainer, and index matching material. A protecting for fiber can have an optical performance as good as fusion spliced fiber or glue spliced. But in case of single mode fiber, this type of splicing cannot have a stability of loss. And next is fusion splicing. Fusion splicing is an act of joining two optical fibers end to end. The goal is to fuse the two fibers together in such a way that light passing through the fibers is not scattered or reflected back by the splice, and so the splice and the region surrounding it are almost as strong as the intact fiber. If proper care taken and the splicing done strictly as per schedule, then the splicing loss can be minimized, like as low as 0.01 dB per joint. After fusion splicing, the splicing joint should be provided with a proper protector to have the following protections. That is mechanical protection and as well as the protection from the moisture. Splicing machines imported by the BSNL begins to the core profile alignment system that functions which are auto active alignment of the core, auto arc function, video display of the entire process, indication of the estimated splice loss. Next is transmission sequence, like how the transmission takes place. Like first the information is encoded into the electrical signals, like which is shown in the diagram, and then the electrical signals are converted into the light signals where pulses of light is get generated, and the light will travel through the fiber, and a detector changes the light signals into the electrical signals, and electrical signals are decoded into the information that can be the voice, data, or video. That is information output of the transmission sequence. How the information is taken and information gets out. Next, how to conduct the splicing. There are the four steps in conducting of this splicing. That is, strip the fiber, cleave the fiber, fuse the fiber, and protect the fiber. First is strip the fiber, and the splicing process begins with the preparation for both fibers end to be fused. So you need to strip all protective coating, jackets, strengthen members, and so on. And you just leave the bare fiber showing, like it is noted on the cable should be clean. Second is cleave the fiber. A good fiber cleaver is crucial to a successful fusion splicing. The cleaver merely nicks the fiber and then pulls or flexes it. So, to cause a clean break rather than cut the fiber, the cleave end face should be perfectly flat and perpendicular to the axis for a proper splicing. Next is fuse the fiber. When you fuse the fiber, there are two important steps, that is aligning and melting. Firstly, you need to align the ends of the fiber with the fiber optic splicer. After proper alignment, you need to utilize an electrical arc to melt the fibers so you can permanently weld the two fiber end together. Next is protect the fiber. A typical fusion splice has a tensile strength between 0.5 and 0.1.5 lbs, and it is not easy to break during the normal handling. However, it still requires protection from the excessive bending and pulling forces. By using heat shrink tubing, silicone gel, and mechanical screen protectors can keep the spray from the outside elements and the breakage. These are the steps that is included for the splicing. And the next technology is mobile wireless communication. When mobile communication allows to communicate with others in different locations without the use of any physical connection. Where we learned about the mobile wireless communication, mobile antenna system, and a lab on the antennas was also conducted. The history of the mobile phones covers mobile communication devices that connect the wireless to the public switch network, while the transmission of speech by radio has a long history. The first devices that were wireless, mobile, and also capable of connecting to the standard telephone network, which are more recent. First first such devices, which barely portable compared to the today's compact handheld devices, and their use was clumsy. Along with the process of developing a more portable technology and a better interconnection system, drastic changes have taken place in both the networking of the wireless communication and the prevalence of its use. A smartphone becoming a common globally and grown proportion of the internet access now done via broadband, where transmitting or receiving voice and data using electronic waves in the open space. And next topic is antenna. An antenna in the communication system behave like an interpreter between the transmitter and the free space, as well as the free space and the receiver. Antenna are metallic structures designed for radiating and receiving the electromagnetic waves. Antenna transform wire propagated waves into the space propagated waves. A receiving antenna receives the electromagnetic waves and passes them on to the receiver. A transmitting antenna transmits the electromagnetic waves into the space. One side of the antenna is connected to the RF cable, and other side is connected to the environment. Therefore, the surroundings of the antenna have a strong influence on the antenna electrical features. There are the two types of antenna we can see, that is omnidirectional antenna and directional antenna. Where omnidirectional antenna, for example, it is usually a vertical polarized antenna, and the directional antennas focus on the RF energy in the particular direction. For directional antenna, the lobes are pushed in a certain direction, and the little energy is there on the backside of the antenna. And coming to the compositions of the antenna feeder system, many of the components that is included in the antennas, that is antenna jumpers, primary feeder cables, lightning arresters, cabinet top jumpers, and then grounding parts. And next is cellular concept. The cellular concept is a system level idea which calls for replacing a single or high power transmitters with many low power transmitters, each providing coverage to only a small portions of the service area. Traditional mobile services are structured similar to the television broadcasting. One very powerful transmitter located on the highest spot in the area could broadcast in the same radius of the 50 kilometers. Cell is a basic geographic unit of the cellular system, where the term cellular comes from the honeycomb areas into the which coverage is divided, which is shown in the figure, which is the architecture of a simple cellular system. We can see the many different types of cells, that is macro cells, micro cells, pico cells, active cells, and umbrella cells. Macro cells are large cells for remote and sparsely populated areas. The cells are mainly used for density of the population in the country is varied down to the location. So the different types of cells are used, and the microcells is nothing but these cells are used for densely populated areas. Plus, by splitting the existing areas into smaller cells, the number of the channels available is increased, as well as the capacity of the cells. The power of the level of the transmitters used in these cells are decreased. reducing the possibility of the interference between the neighboring cells. Picocells are small cells whose diameter is only few dozen meters. And selective cells, it is not always useful to define a cell with coverage of 360 degrees. In some cases, cells with a particular shape and coverage are needed. Umbrella cells. The freeway crossing cells, very small cells, produce an important number of handovers among the different small neighboring cells in the case of fast-moving mobile subscribers. Mm. Next is featuring of a digital cellular system, like a small cells frequency reuse, small or battery power handsets, performance of the handovers. Small cells, a cellular system may use of the base stations, which relatively small coverage radii on order of a 100 meter to 30 kilometers. Next is frequency reuse. The spectrum allocated for a cellular is limited. As a result, there is a limit to the number of channels of frequencies that can be used. Small or battery powered handsets, in addition to supporting much higher densities than previous systems, this approaches enables the use of a small or battery powered handsets with radio frequencies lower than the large mobile units used in the earlier systems. Performance of handovers in cellular systems. Continuous coverage is achieved by executing a handover, the seamless transfer of the call from one base station to the another as the mobile unit crosses the cell boundaries. That is conclusion of the cellular concepts and different types of cells used in the GSM technology. Tech, Techniques like sectoring and cell splitting are introduced to improve coverage of and capacity of the mobile network. Next, coming to the generation of the mobile, which is the last slide of the presentation. From the early analog mobile generation 1G to the last implemented third generation or fourth generations, the paradigm has changed. The new mobile generation do not pretend to improve the voice communications experience, but try to give the user access to the new global communication reality. The aim is to reach the communication ubiquity every time and everywhere, and to provide users with a new set of services. The growth of the number of the mobile subscribers over the last years led to the saturation of the voice over oriented wireless telephony from a number of 240 million subscribers in 1990 to 1.162 million in 2002. It has increased to 1,700 million subscribers worldwide in 2010 and increasing day by day. It is now time to explore the new demands and to find the new ways to extend the mobile concept. The first step have already taken by the 2.5G, which give the users to access the data network. Example, internet access MMS, where the internet speed is given in a table, where the speed of this 2.4 kbps to 14.4 kbps, and multimedia message services. After that, there was a 3G multimedia support, spectrum transmission, and 2011, all the IP switch networks, the 4G comes, where 4G is a fully updated and a present version in India, that is LTE and WiMAX, other technology which can be used, speed of the data rate which can be up to the 100 Mbps, but in 3D generation where we can give only 3.5 Mbps, and there has been a clear shift from the fixed to the mobile cellular telephony, especially since the turn of the century. By the end of 2010, were over four times more the mobile cellular subscriptions than the fixed telephone lines. Both the mobile network operators and the vendors have left the importance of the efficient networks with equality efficient design. This resulted in network planning and optimization services coming into the sharp focus. Next generation's mobile networks, commonly referred to as 4G, and are indicated as a multitude of the heterogeneous system interacting through the horizontal IP-centric architecture. The 5G core is to be reconfigurable multi-technology core. features are features of the first generation mobile is voice only, and coming to the second generation, multiple user can use on a single channel, and coming to the third mobile generation, which supports a video call and multimedia features, and the fourth generation, which calls a high speed and real time streaming. Thank you.